Okay, so I'm going to add more 120 over here. Okay, I think I need to add. Okay, then we are going to do the shear. Okay, so the shear is 30. So does not matter. I know this is positive shear, but for shear we have to draw both positive 30 and negative 30. Okay, I know this is positive shear, but whether is it positive or negative on Mohr circle, it all dependent on the rotation of the what? Element. Okay, that's why you draw the positive 30, you draw the negative 30. Okay. So the next thing we're going to do, we are going to look at our 60 value, point X. Okay, so we know that this is our stress X line. You know that this is your stress Y line, right? So from here, let's look at our stress X line. So stress point X is the element of the 30 megapascal is going to rotate in what direction? What direction is that? Anti-clockwise, on top or below? So there's your point X. Okay. I will do this again in point Y. Okay. So now if we look into point Y, we look into point Y, this arrow over here, the blue arrow, is going to induce the element rotation in the what? In a clockwise direction, right? So this is on top. Not that difficult at all, isn't it? Right? So from here, you draw a straight line across. And then from here, you know where it intersects. Over here, this is your point O, center of your circle. So you draw a vertical line down. So in your exam, you have to physically calculate that value. Okay, your circle can just be a sketch. I'm fine with that. Okay, so from here, we are going to determine the center of circle. Center of circle is equal to your stress average, right? So your stress average is equal to stress X plus by stress Y divided by 2. Average means you add them together, yes or no, right? So it's equal to minus 60 plus by positive 90 divided by 2. It's equal to positive 15 megapascal. Okay. So the procedure is very fixed. Okay, first you determine the center of your what? Circle. Very fixed. Okay. The next one, you determine the radius of the circle. Right? So which is also equal to your tau max. So your tau max will be equal to what? Okay. No need to memorize anything. Just look at the circle. What do I mean? What do I mean? So we know the distance from here to here, right? We are aware that the distance from here to here is what? Is equal to 30, right? And then we also know the distance from the shear average to here, right? This is equal to, wait, let me draw bigger a bit. So this distance is 10, 20, 30, 10, 20, 30, 40, 50, 60, 70, 75. Okay. So from here, we just do 30 squared plus by 75 squared is equal to 30 squared plus by 75 squared is equal to 30 squared plus by 75 squared, square root the whole thing, 80.777. So I think I need to add in 100 negative and 100 positive. Okay. Then from here, I can determine our stress 1 and 2, or we can determine our principal stress. Okay. So stress 1 and 2 is equal to stress average plus minus by your what? Tau max. So this is equal to 15, positive 15, I do apologize, plus or minus 80.777. So we have two values. Okay. So one is positive 85.777. The other one is 65.
95.
Oh, 95. You're right. Hey, how come I write 85? You're right. 95.777. The other one is 85.777. So now, okay, those of you that have a compass, after you calculate your stress average, you can draw the circle already. Okay, you don't need to calculate the stress average, the principal stress. So now you get 65.777, and then you got your 95, 95.777, and then a bit over 80, and a bit over 80. This is your Mohr circle now. Okay. So this belongs to your XY plane. Okay. So now, where are we now in our question, right? Is it straightforward? Is it easy? It's not that difficult, yes? Right? So where are we now in our question? Okay. We have determined stress average. We have determined our tau max. We have determined our principal stress. Next, we are going to determine our principal plane. Okay. So principal plane, you can either take from point Y or point X. I repeat again, you can either take from point Y or point X. What do I mean by that? If you take from point Y, right, this angle from here to here is equal to 2 theta P. Y2 theta P on Mohr circle is 2 theta P. Yes or no? On the element is what? Theta P. Okay. So you can take it from point X, or you can take it from point Y, or you can take it from point X. The answer will be the same. From point Y to stress 1 and stress 2, so I'm going to label this stress 1. Okay, I'm going to label this stress 2. Okay. So to stress 1 or to stress 2, from point Y to stress 2 and point X to stress 1, the angle is the same, yes, and the rotation direction is the same. Are we clear? So either point you take, either from point X to stress 1 or point Y to stress 2, the values will be the same. The orientation will also be the what? Be the same. Okay. So to calculate that is high school math. Right? So we do geometry, tangent. Now we're going to calculate our principal plane, which is our theta P. Okay. So we know that tangent to theta P is equal to 30 divided by 75. So we get 2 theta P is equal to 30 divided by 75 inverse tangent. It's equal to 21.8 degrees. Let me do it again. 30 divided by 75 inverse tangent. 21 point. So theta P is equal to 21.8 divided by 2 is 10.9 degrees. And the direction is what? Clockwise. Why clockwise? From Y, from Y to here, the rotation is what? Clockwise, yes or no? From X to stress 1 is also what? In the clockwise direction. Okay. Okay, what have we accomplished so far? Okay, what have we accomplished so far? We are now, or you are now capable from dealing the element to what? Element to Mohr circle. Yes or no? You can transfer the information from the element to Mohr circle. When we come back from the break, we are going to transfer the information from the Mohr circle to the what? To the element. Because the element is the what? The real world. Mohr circle is the what? Analysis. So now we know where the principal plane are. We have to bring it back to the what? The real world. Okay. Go for a break. We come back in 10:45. Scroll down. I'm going to stop recording first, okay?